starting recording and transcription.
Okay, perfect. Perfect. Thank you. Okay, so good afternoon, everyone, and welcome to this session. This is part of the SASA, South African Statistical Association, Spatial Stats Interest Group. Usually Inga does the introductions and so on and leads the discussions, but Inga is not available today, so she's asked me to do this. Part of this group, Inga is the coordinator together with myself and Renata, who has also joined us as well. So today we will be enlightened by a talk by Professor Gregory Breetzke. I hope I'm pronouncing your name correctly. He's from the Department of Geography, Geoinformatics, and Meteorology from UB. So just a bit of background on Greg. So his formal education include an MSc, which he obtained cum laude in GIS from Vrije University in Amsterdam, in the Netherlands, and he also obtained his PhD in geoinformatics at the University of Pretoria. His research focuses mainly on geospatial analysis of crime and criminal offenders. He has over 100 publication outputs in areas such as spatio-temporal crime analysis, crime seasonality, fear of crime. I should have started my camera, sorry. So fear of crime, gangs, and geodemographic offender profiling. Prof. Breetzke has appeared on various media platforms in a number of countries and has been invited to present at numerous academic conferences, symposia, both locally and internationally. He has won numerous local and international awards for his research and has active research collaboration with colleagues in various countries. Finally, he's a member of various organizations, including EXA. I always thought that was the Engineering Council for, EXA, which is an informal association of leading international scholars in the field of environmental criminology, crime science, situational crime prevention, and intelligence-led policing and problem-oriented policing. Okay, so he's going to speak to us. As you can see, the topic is on his slide: the use and potential of spatial statistics to examine crime in South Africa, and some examples and excuses. Okay, so I think it will be quite a good talk. So, Greg, I hand it over to you. Thanks, Tinus.
You can hear me?
Yes, I can hear you.
Thanks, Prof. And thanks, everyone, for this opportunity. Inga invited me to speak to you a few weeks ago, and I was happy to take up the challenge. I thought for the overview, she's given me about 40 minutes, she said, roughly, to speak. So I don't know if I'll take up all of your time, but I will cover these sort of topics. I thought I'd give you some idea of my academic and research background, my research, broadly speaking, and then some examples of work that I've done since my PhD about 15 years ago. These are purely snapshots, so it's a very broad brushed, kind of one slide per example of work done, and conclude with some excuses. I'm a bit facetious in using that word. It's more of a I got, I guess, a level of frustration and the difficulties that spatial crime researchers, I guess you could say, have in South Africa when attempting to generate knowledge and information and intelligence that can be used to have an impact on crime reduction and crime prevention. Before I start, I'd like to lower expectation at point of engagement. A colleague of mine once said, and that's just to say that I'm not a statistician. I did stats, I think 1 or 2 years of undergrad in stats, but my undergrad was in geographical information science, and of course spatial analysis and spatial statistics form part of the tools and techniques that you can use to better understand a range of phenomena, including health and crime, and so a lot of the tools and techniques that I've used together with colleagues in various projects and papers that I'll outline, I know the utility of these techniques to better understand a certain phenomenon, but the real statistical nitty-gritty, I would say that I'm less well versed in, but I'll hopefully illuminate some of the research that I have done, and you will see the potential of spatial statistics to better understand crime phenomena in the country. My background, very briefly, I was one of the first, the University of Pretoria was one of the first, if not the first university in the country to offer a geoinformatics undergraduate degree in the mid-1990s. This has been, if you're unfamiliar with GIS, it's got a kind of like an intelligent computerized mapping application in which you can do a whole range of spatial analysis and spatial statistics. The geostatistical extension to Arc Pro, which is a very industry-led software, is limited. It certainly doesn't have the capability of statistical packages like Stata, for example, but it does have geospatial application. So I did that and went on to do a honors and a master's overseas, and then back to do a PhD. And then my journey took me through the University of Pretoria and Canterbury in the geoinformatics as a lecturer in geoinformatics. I was there for about 5.5 years. And one of the many reasons I left, and I get this question asked a lot, was the Canterbury earthquakes which occurred. This is Christchurch, and this is the moment that an aftershock actually hit Christchurch in February of 2011. The actual earthquake occurred in September of 2020. What many people, if you haven't experienced an earthquake or lived through it, don't realize that it's more the aftershocks that actually impact you. I think in the September 2010 to September 2011, there were 14,000 aftershocks in Christchurch. Christchurch, from a geographer's perspective, is built on an alluvial fan between two mountains, and the major issue there were the liquefaction rather than the destruction of buildings. I returned to UNISA in 2014. I was there for a short time, and then I took up an AP position at the University of Pretoria about 6.5 years ago, and this is where I've been ever since. In terms of my research, I guess you could broadly categorize my research as lying within environmental criminology, but of course, environmental criminology is also very broad and consists of quite a lot of, I guess you could say, subdisciplines. Broadly speaking, it's a discipline that attempts to identify how the place in which you are, however defined, whether it's a neighborhood or a street segment or a neighborhood block, how that impacts your crime risk. And of course, within that, there's a lot of theories that can be unpacked. But within environmental criminology, there's, I guess you could say, 3 types of analysis that you can undertake. You get conventional crime mapping. This is mapping of rates and general statistics on crime. At its very most simplest level, it would probably be the SAPS's quarterly release of the crime statistics. Then you get spatial analysis, and within this, there's a whole range of techniques that can be used to analyze crime incidences. And then ecological analysis, which tries to identify causes of crime by looking at various, using mainly regression and pretty much every type of regression you can find, trying to understand crime risk. So it's within these, I guess, three broad areas within environmental criminology that I've attempted to better understand crime. Within my particular research interests are pretty broad. This is, I guess you could say, a summation of the last 15 years or so. I've done work on in South Africa on a range of topics. I signed a research agreement with New Zealand Police just before I left, and I'm still actively involved in undertaking particularly gang research in New Zealand, and then a whole lot of recidivism research. Recidivism is a return to crime. So each country, including South Africa, will have a recidivism rate. That's the rate of people that return to prison, usually within a year of being released. So most countries have about a 40% recidivism rate. So about 40% of offenders are back in prison within a year. And New Zealand, that is one of my mandates for the research agreement I signed with them, is to investigate the kind of spatial causes of that. And I'll touch on one paper project towards the end of the presentation, in which we looked at one risk factor that increases recidivism. Some of these I touch on in the next half hour or so. Again, it's a very broad brushed, but I thought the way in which to structure this presentation is kind of rather to overwhelm you a little bit with the use and potential of a number of statistical techniques that I have used to try and understand crime in the various contexts in which I've investigated it. And hopefully it kind of sparks something amongst the listeners and gives you ideas. And of course, I'm welcome to engage with anyone, either through this forum or personally and privately in other related topics or associated topics. Before I start with some of the examples, the importance of data cannot be understated. And this is, I'm kind of jumping ahead a little bit because this is some of the excuses. And there are people in this seminar that were well versed in the real challenges of getting access to spatial crime data in South Africa. That requires another seminar in itself. Suffice to say that as statisticians, you will know that it's very difficult to accomplish anything, especially in applied statistics, if you don't have access to data, whether it be survey data or point crime data in my example. And of course, data like this is data of crime, burglary and theft within Christchurch. The area in the middle that doesn't have any crime incidences, that's Hagley Park, which is a park located in the middle of Christchurch. I think it's the fourth biggest inner city park in the world. If you don't have data, you can't really accomplish much. And of course, data has crime data especially has its limitations, notably underreporting. And also, for example, crime being reported or over-reported or biased within the crime of who reporting crime. Just as an example, when I arrived in Christchurch at the University of Canterbury about 10 years ago now, or possibly a little bit more, there was a massive newspaper article in which someone had done burglary clear-up rates in Christchurch, and they had found that most more affluent areas were more likely to have a clearance rate for burglary. And of course, this became a headline in Christchurch about how the police don't care about poorer neighborhoods that suffer property crime. And so it's extremely a contentious issue, and police especially are extremely guarded about releasing this information. And of course, if you're a spatial crime researcher, you heavily rely on it to generate any output. So it's a challenge and something that that is particularly difficult in South Africa. Before I start with my work, I thought I'd just show two slides on some really early work that was done and very rudimentary statistical analysis, or if any at all. But it's worth mentioning just because it shows that even though a lot of this work was being done in the United States 25 years ago, Professor Larry Zitzman at Stellenbosch was doing a lot of this kind of very rudimentary mapping and looking at associations between crime, in this instance in Paarl, in the Western Cape, and land use, for example. So this is a map of various types of crime occurring in Paarl. There's a little table there that just shows some of the very basic information. So it's not very rich data, but it's some information about the proposed date of the crime, when it started, and the address in which it occurred. These were mapped, and this is a paper in the South African Geographical Journal in '98, in just looking at differences between the daytime and nighttime. This is before the advent, well, I guess before GIS really became mainstream, and so a lot of these maps are hand-drawn maps. And here, this is a map of a very kind of crude representation of land use in Paarl, and overlaid on the land use is various types of crime. And the majority of crime in Lady Grey Street, which you see towards the top center of this area, with the idea being that property crime is more prevalent. This is a very exploratory study, so it's not very analytical. And the more, I guess, the furthest the paper got was looking at the kind of diffusion of crime around 3 police stations located within Paarl. And the distance zones around the police stations are done by road traffic distance, and not Euclidean distance. And the idea was to see whether within various buffer distances around the police stations, how many street segments contain how many crime, a percentage of crime. So this is kind of, as they say, standing in the shoulder of giants and what have you. This is really one of the first pieces of work that tried to look at some kind of spatial association. I wouldn't even say it's a statistical association between police station locations and crime incidences. It was more the advent of computerized mapping through GIS, and GIS becoming mainstream, that kind of opened up crime analysis, I guess you could say, to more quantitative techniques. And these are just some of the statistical techniques that have been used to examine crime phenomenon. This, coupled with journals that emerged, and I've put 2 there, that publish mainly quantitative studies that identify crime causation using some extremely advanced statistical techniques. I was at the recent CRIMSA conference in Johannesburg, which is the Crime and Victimology Association of South Africa, and I would say 95 to 98% of presentations were qualitative. Criminology and criminal justice in South Africa has a very strong qualitative history, and that leaves very little space for quantitative research to be taken. And this is very sad and very unlike what's happening internationally, where criminology is not kind of confined to the humanities and the arts and mainly investigated using qualitative techniques, but it's also has a very strong quantitative background. So I'll jump into some of the examples, and these range from my PhD to more recent studies. This is the main, I would say, tool that I've used, although less so recently, to examine crime is regression and a range of different regression types. So at its very simplest level, an OLS regression in this study with my PhD supervisor about 15 years ago was trying to understand what predicts offender development in the city of Tshwane. So here, the left-hand side, you've got a map, a rate map of offenders per 1,000 people aged over 18. So the data we obtained through the Department of Correctional Services in South Africa was the location of about 2,000 offenders who were incarcerated at about 4 correctional centres across the city of Tshwane, including Atteridgeville and Odie and obviously CMAX and the medium prison. These were address matched, and I think this project started with looking at 250 census variables, and we eventually cut it down to about 100 census variables. We ran a correlation analysis on these census variables to identify their association with the offender rates. We reduced it down to 30 that were significantly associated with offender rates at the neighborhood level, used factor analysis to identify 5 factors, and put those 5 factors into a regression model to identify those factors that significantly predicted offender development in the municipality. And it's the usual suspects in terms of offender development, and that's mainly social status and income and incomplete families and mobility. I extended this work a little bit more, where we looked at different types of offenders. So obviously violent, economic, and sexual. It can go down finer, and a similar kind of spatial pattern emerges if you look at their distribution across the city. This is obviously done before the expansion of the City of Tshwane Metro, I think in 2011. So the city now expands towards the east, but this was obviously prior to the expansion. And here we looked at, again, using, in this example, ESDA, which is an acronym for Exploratory Spatial Data Analysis. These are various types of tools that are mainly used to visualize spatial data using box plots or parallel coordinate plots. Very rudimentary techniques that just, attempt to try and describe the spatial patterning of that phenomenon. We also use spatial regression in this example to identify whether different types of factors predict the spatial patterns of different types of offenders in this particular paper. And we found, much like the spatial map indicates here, that the same kind of predictors predict the distribution of different types of offenders. Within the ESDA component of the paper, we looked at the spatial clustering of offenders using a Moran's eye. And here you have 3 maps of the violent, economic, and sexual offenders, and the various positive spatial autocorrelation and negative spatial autocorrelation. At this point, I guess I was kind of in the middle of my PhD and finding my feet a little bit in terms of looking at the ways in which different tools exist and how we can understand crime, and in this example, offender development. The last kind of component of this work, and where I kind of, after this, I kind of pivoted towards looking more at crime incident locations and less at offender locations, was a geodemographic profiling system that was developed to identify kind of at-risk areas for future offender development. So it is a bit spatially deterministic, but the tool we used here, or I used here, was K-means cluster analysis. So just a bit of a background, geodemographics attempts to group neighborhoods together on the basis of social similarity and not on geographic proximity. So neighborhoods can be geographically distinct from each other, but they can be in the same cluster if they have similar attributes. It's been used a lot in spatial analysis and GIS, but less frequently in crime analysis. This map over here is Charles Booth's map of London in 1889, and this is the primer for modern day geodemographics, and he went street to street in London and through school board visits, and he constructed this legend you see on the right hand side, in which he categorized different streets in that particular part of London based on what he perceived to be the profile of people living in that street. So it was obviously color coded, and you can see no one would want to be classified as the lowest class, vicious and semi-criminal. I do enjoy these old maps. And so we used a similar kind of tool in K-means cluster analysis to cluster the city of Tshwane based on I think it was based on the 30 variables that I mentioned a slide or two ago. We generated 7 clusters, and using the cluster, the variables that were kind of loaded onto each cluster, we were able to generate this risk areas, which is shown on the right-hand map. Interestingly, and one of the kind of strengths of geodemographics is that a number of the areas that were classified as high risk for future offender development actually had a low offender rate, a low current offender rate, but their socio-demographic profile was very similar to other high-risk areas. So therein lies the strength of I actually gave a lecture to my third-year students last week on cluster analysis, and that's what I said, the biggest power of cluster analysis, even within a crime example, is to find hidden patterns in your data, but when you're using spatial data, you now can map that, and the challenge is often to not only identify the hidden patterns, but try and explain it. So the location of offenders, as I mentioned a slide or two ago, was found to be associated with those four broad factors. My career at this point kind of pivoted away. It was at this point that I managed to obtain a number of crime data sets, point crime data sets in South Africa. It also coincided with me leaving to New Zealand. But throughout my time in New Zealand, I kept up research in South Africa. So I'll start here with kind of very basic rate mapping, which I did together with numerous colleagues. You can see at the bottom. This is one with Ian Edelstein at the HSRC at the time, who was at the HSRC at the time. Here we looked at crime concentration of South African townships, a South African township in particular, and that's Khayelitsha, which is a very high crime community. And here we looked at, there's a very common law of crime concentration in the literature, which says that much like the Pareto principle, 80% of crime will occur in 20% of locations. And here we looked at 3 different types of crime. And over this study period, we wanted to see whether on the y-axis, with what percentage of small areas or neighborhoods or subplaces contained 75% of crime. And we can see across different crime types, and there is some temporal stability here, that roughly 20% of small areas account for 80% of crime, even in a high crime context, such as Khayelitsha. So often we hear of incidences occurring in Yanga or Manenberg or Khayelitsha, 3 townships in the Western Cape, and who are often in the top 10 most violent police precincts in the country. And we often think that the crime is kind of uniform, but this is not the case that we found here. More recently, a master's student of mine, Kayla Teron, has done some work down at the street segment level. This is a map on the left-hand side. On the left-hand side, you can see very similar to the previous slide, but here this is based on the street segments. So in her work, she was able to also within Khayelitsha snap each point location to a street segment. And on the left-hand side, according to three crime types, property violence and sexual, what percentage of crime occurs in percentage of street segments. A street segment is a much more useful identification of risk, because you're able to direct patrols or resources to certain streets and not to certain the neighborhoods, which can often be quite big. So if you look at the bar charts on the left-hand side, you can see, for example, that 42% all crime, 42% of all crime occurred on 42% of property crime occurred on 42% of street segments, but 75% of crime occurred in 19% of street segments for property crime and 23% of for violent crime. In fact, she actually found that it was something ridiculous, like 50% of all crime in Khayelitsha over a study period, and I think this was over a period of 3 years, occurred in 11 kilometers of road. So if you think about 11 kilometers of road accounting for 50% of all crime over the study period, it's a different way of understanding risk. And she's actually busy with another part of her research is looking at the causes of high crime at the street segment level. So much like in the offender development research, a lot of my after kind of mapping rates of crime, a lot of my attention is focused on using various types of spatial regression techniques, spatial lag models, spatial error models, to understand why crime occurs. It concentrates in the city of Tshwane, where I also received data. A lot of the time in the work I do, you need to embed your work within some kind of theoretical framework, certainly in order for it to be published. So you will see in the title of the first paper or project, we used something called social disorganization theory, which is a theory almost 100 years old now that is commonly used to explain why crime occurs in neighborhoods. And it's a Western theory of crime developed in Chicago, and it was used in this example to understand violent crime in Tshwane. In the second study at the bottom, I looked to see whether, using spatial regression, the same predictors predicted crime in neighborhoods stratified by racial groups. So we looked at black neighborhoods, predominantly black neighborhoods. Those are neighborhoods in which more than 75% of residents, according to the census, identify as being black African, similar to white, and we had mixed neighborhoods. And we saw whether the predictors of crime varied by neighborhood stratified by racial group, and there were notable differences found. I think percentage absent father was a very strong predictor of crime in black African neighborhoods, and unemployment was a very strong predictor of crime in predominantly white neighborhoods. So these are the kind of types of regressions we use, with the dependent variable being violent crime or different types of crime, and the independent variables most often informed by some spatial crime theory, which is inherently some kind of Western theory, but applied in a local South African context. To pivot back to
Greg,
yeah.
before you go on, Don has his hand up. Don, is it a question that can wait for at the end of the session? And Greg, do you mind taking the question now?
Sure, no problem.
Okay, Don, if it's a quick question, you can go ahead.
Thank you. It's actually not a question. It's I couldn't see the slides, so I just wanted to check if it was only me. But now I can see them. It's fine. Thank you.
Okay. Thanks, Dan. Greg, you can go ahead.
Okay. Yes. So to pivot back to my so I guess the two focus areas of my research has been the city of Tshwane, which obviously where I grew up and I'm currently employed. And then in a lot of township communities in the Western Cape, where I've got a lot of contacts and colleagues working there who I work with. This is work done looking at the kind of spatial diffusion of sexual violence around schools in Khayelitsha, sorry. This is around looking at 55 schools in Khayelitsha. The map you see over there, the red points represent schools, and the yellow points represent crime. They're just draped over a Google map. Here we used, with the help of Inga, who you all know, a multi-type K function to see whether there was any kind of clustering of crime, of different types of crime around schools, and we did find some evidence for clustering of sexual violence around schools in Khayelitsha, which is obviously somewhat concerning. We extended this work a little bit further and used something called intensity value analysis, which I guess you could say is kind of like an advanced buffer analysis. Here, what the tool does is it looks not just at the kind of density of crime around a school, for example, but it looks at the intensity, it measures the intensity of crime around a school or a shopping mall based on its distance away from the school or the shopping mall, using some kind of function that you would apply to that distribution of points around a facility. So here we expanded this and we looked at schools. There were only 20 schools, as you can see in that particular table, because here we only looked at one police precinct within Khayelitsha, and in the previous study we looked at three. There's 3 police precincts in Khayelitsha. Here we only looked at one. Recreational hubs are shopping malls, and transport interchanges are mainly taxi ranks, for example, and train stations. And we looked at measuring the intensity of crime around 100 meters and 200 meters. This result particularly is robberies, but we also looked at assaults and rape. And we compared that to random points and whether there was a significant difference between the intensity of crime in around these facilities compared to 100 random points around the township. We found an increase in robberies within 100 meters of a transport interchange, and within 200 meters of all 3 facilities that we looked at. And we also looked at identifying which percentage of facilities have 50 or more robberies around within 100 meters or 200 meters. because it could be that there's one transport interchange, for example, or a handful of the 14 that are particularly problematic. But of course, that's masked out by the averaging of all to see across all transport interchange. So we're wary of that criticism of this work, and we try to kind of factor that in by including that number. So here in this example, we'll use dummy variable regression to look at seasonal assault. This was done with a colleague, Ellen Kahn, who's from Florida, who's probably the world's expert in crime seasonality research. So here we looked at to see whether assault in the city of Tshwane was seasonal. And you can see on the map on the left, or at least on the graph on the left-hand side, that it broadly follows a seasonal pattern with assault. Interpersonal crime is generally peaks in summer when people are more outdoors and most often consuming more alcohol and more likely to be in contact with other people, and generally is lower if you look at the observed and expected monthly frequency in the winter months when people are not outdoors as much. But we wanted to see whether that trend was uniform across neighborhoods stratified by social deprivation. So in the city of Tshwane, we divided neighborhoods into a social deprivation quintile, ranging from very affluent to very poor. And in the table on the right-hand side, the month of the year, you've got the amount of assaults that occurred in each month. And then you have the assault occurring per deprivation quintile. We constructed a Q5, Q1 ratio to see whether this was the case, and then we ran a simple Spearman's correlation to see if there was any association. And we did find a little bit, not as much as we were expecting, but we did find some differences in seasonal assault by neighborhood quintile. There's a lot of research, particularly in the United States, that shows how crime seasonality very much adversely affects the poor more than the more affluent, because the more affluent have ways of escaping heat, for example, putting an air conditioning on or swimming in a swimming pool, whereas less affluent are not able to do that. So we found a little bit of evidence for that too. In this example, another regression type, we used geographically weighted regression. This is more of I guess you could say, a fun study that was born out of an interest that I got reading an article that showed how suicide, for example, in the United States varied by altitude at the county level in the United States. And this was a kind of a take on that. And this study looked at, again, on the map on the left-hand side, you're seeing the suburb outline of the city of Tshwane, and it's draped over what's called a digital elevation model. Digital elevation model is a common tool used in GIS, particularly in physical studies that looks at elevation. And here on the right-hand side, you have distribution of crime points across the city of Tshwane. And we looked at, we used something called zonal statistics in GIS, which calculates a whole range of descriptive statistics for each neighborhood based on the characteristics of the digital elevation model. So you could get, for example, the mean and the median and the minimum and the maximum and the standard deviation elevation per neighborhood from that analysis. And we used that as input into geographically weighted regression to see if there was any kind of association between altitude and slope in particular and burglary risk. The idea or the notion here is that certainly in Western cities, well, I wouldn't say Western cities, but in Europe, for example, it's more affluent people that live on higher altitudes and in higher, steeper slopes. If you think of Pretoria as well, most often more affluent neighborhoods, or at least neighborhoods that are affluent, are more likely to be in those locations. In South America, it's the opposite. More affluent are more likely to be in lower altitudes and in lower and in flatter slopes. So we did find some evidence here for a reduced burglary risk at higher altitudes and in steeper slopes in the city of Tshwane. This study looked kind of focused on the temporal aspect of crime in the city of Tshwane. Again, here used something called Fourier analysis, which is a tool that tries to identify periodic sequences of data. It's mainly used in engineering, I believe, with very few applications in criminology. So you'd probably be familiar with the temporal resolutions shown below, and this is an example of violent and property crime in Tshwane on the left-hand side across the year, in the middle slide across the days of the week, with generally the peak being on Friday and Saturday, and then on the days of the hours of the day in the far right-hand slide, where you can see that violent crime generally peaks in the early to late evening, and property crime, this is in the city of Tshwane, property crime is most highest during the day. This is most often the case because people are at work or away from their homes and leave the home unoccupied, and this increases property crime risks such as burglary. And it drops dramatically during the evenings, as you can see, when people are more likely to be at home. So these are the common kind of spatial temporal factors that people are aware of. We used Fourier analysis to try and understand day periodicities of crime. So I'll try my best to explain this. So basically what you have C on the y-axis is the day periodicity, and on the x-axis you have the percentage of crime. So this is the percentage of crime occurring at each day period. So the biggest spike you can see, if you look right at the top, occurs roughly at the seventh or eighth day. This is across both violent and property crime. And the reason for that is because what happens every 7 and 8 days is the weekend. So crime generally peaks on the weekend, and you can see violent crime in particular peaks extremely high during the weekend and has some periodicity there. The next biggest peak for both violent and property crime was at about the 80-day mark, where you can see about 5% of crime over the study period, and I think it was about 6 or 7 years. So this, my colleagues and I were really baffled at what occurs every 3 months, or just under every 3 months, 2.5 months, or just over 2 months. What occurs, we were trying to think about what occurs every 2 months over the 6 years that could increase property crime risk. And in the paper, the best explanation we came up with was school holidays, which we thought could explain this periodic peak in property crime that occurs every 80 days. But of course, we speculated on this quite a lot. We then deep dived into the periods, and we stratified it, much like a similar study. We stratified the periodicity by neighborhood quintile. So I've just shown two here. So the quintile 1, quintile 2, this is the poor neighborhoods, and the the violent and the property crime VQ3 and property crime quintile 3. That's, I guess you could say that's middle class. And you can see that what's basically driving the 90-day peak or the 80-day peak is something that's occurring in middle class neighborhoods, because it doesn't exist in upper class neighborhoods on the quintile 1s you can see on the left hand side. So this confused myself and a colleague who worked on another follow-up paper on this even more, because of course school holidays occur everywhere and not just in middle class neighborhoods. So any ideas would be welcome there. I'm kind of this is another piece of work done by a student of mine, Nicholas Kemp, and a colleague, Anthony Cooper from the CSIR, in which we built a robbery prediction model for the city of Tshwane. So here you have the expanded city of Tshwane metro. We use something called risk terrain modeling. This is a spatial diagnostic tool that attempts to combine, I guess you could say, facilities or facilities that occur in the built environment. So on the left-hand side, you've got these various facilities that occur in any city: liquor stores, drug stores, a bank, a petrol station, a hotel, a park. And risk terrain modeling attempts to find where these facilities co-locate and assigns a weighting to them and combines these various layers of data based on a weighting that you specify, and that results in this kind of jeopardy surface that you can see on the right-hand side, which is, in his example, looks at identifying what increases a robbery risk. And we did this based on existing data. The idea here is that you can predict with relative certainty And of course, you can use a training model, a test model, and training data set to see how well it predicts in the future robbery risk. I think the facilities that we used here for this model in particular was the location of commuter nodes. So we noticed how there was an increase in risk and crime, particularly robbery there, and we multiplied that with other facility data, and we multiplied that with a social deprivation index, which he developed at the neighborhood level, and to result in this map. Of course, it gets more complicated than that, but just to give you some idea of the kind of, in GIS, you would call it map algebra, where you are able to combine different maps using different formula and different algorithms to come up with something, not a number if it's aspatial research, but actually a map, which hopefully tells you something about the particular phenomenon being investigated. So here, I'm coming towards the end. This is another example in which we used a generalized additive regression. I must say that this is not my particular strong suit. When we start to deep dive into regression in much more detail, this is where I get a little bit lost. But in this example, myself and colleagues from Norway and the ISS, Institute for Security Studies, and Rhodes University looked at doing the first study of its kind in Africa, and that's looking at the association with green space and crime. So there's current notion that neighborhoods that are greener, cities that are greener, municipalities that are greener have less crime. The reasons are ranged from physiological, because living in a green area is better for your physical and mental well-being, to sociological, saying that greener areas are more likely to have people that move around and are friendly to each other. And so we looked at this example here. We looked at this at a national level. So we had data at the police precinct level in South Africa. That's the map you see on the right-hand side. That we used like something called a tricolor palette, which is a kind of mashup between sexual, violent, and property crime, and each police precinct occurs somewhere within that tricolor palette. And that is the crime rate distribution mapped at the police precinct level. On the left-hand side, you just see a general annual crime rate count per 100,000 citizens for the various types of crime, the pink being violent, and the blue being property, and the yellow being sexual. We use these models to see the impact, the independent effect of various green variables. We had a number of green space variables: proximity to the nearest park, total green space for each police precinct, and the percentage of the police precinct that had tree coverage. And we found for increases in green space, there were reductions in violent crime and property crime. And for an increase in tree cover, we did find decreases in violent crime, but actually a marginal increase in property crime. And we obviously control for a whole number of other covariates, which you see at the bottom there. And those covariates are often common predictors of crime, things like unemployment, percentage youth. Obviously, inequality is often a very common predictor, and various types of land cover. As a final output for this particular study, we mapped the nonlinear interaction effects of the percentage of on the response variable. Look here at the percentage green space on the total green space rather, and green space coverage, to see if there was any kind of effect between the two. So if we look at the middle one in property crime, we can see crime was generally quite high, where there's low green space but high tree cover. So we teased out a lot of these kind of anomalies in the data, and this is, I guess, one of the nice strengths of spatial statistics, if I can kind of loop back to that, as opposed to traditional statistics, in that spatial statistics allows you to generate these kind of output, which I think is certainly in my research interest, and something that I like to do, because it allows you to kind of visualize some of your results. Then the last study, and this is a study on some of my New Zealand work, I thought it was worth mentioning. Here we used a multi-level regression. I partnered with Devin Palaszczuk, who's one of the leading recidivism colleagues, academics globally, and here she had a data set on 280 high-risk parolees that were released from prisons across New Zealand, and these parolees were interviewed and surveyed every 3 months post-release for a year. So they were interviewed 4 times after their release, and each time they were surveyed, they would ask a whole number of questions. What we looked at is we determined whether they were incarcerated 1 year after the release. Those that were incarcerated 1 year of release were given the value of 1, let's say, and those that were not back in prison were given the value of 0. We had a whole lot of independent, individual level variables about each parolee. We knew their age, their ethnicity. This was mainly Maori or non-Maori. The age of their first conviction, the number of parole conditions they had, how many days they served. So the idea there was that if you served a very long sentence, you're more likely to recidivate, come back to prison, than if you served a very short sentence. Then 2 scores that the Department of Correctional Services give to each parolee based on a whole lot of background statistics. And then, of course, we knew the neighborhood in which they returned to after they were released from prison, and we identified a number of variables that we thought could predict whether they returned to prison, including unemployment, the AO cells for alcohol outlets. So this was that the Department of Correctional Services were particularly interested in if they returned to neighborhoods that had facilities like gambling facilities and alcohol outlets, if that increased their risk to recidivate. Male age and a whole number of other variables, and then the idea here was to say whether people moved a lot, if they had more than one address over the year post-release, if that increased their chances of going back to prison. And at the neighborhood level, we also looked to see if they moved back to a neighborhood in which there was a lot of mobility, a lot of people that moved in and out of that neighborhood, if that also increased their recidivism rate, and we did find some evidence for that. So this is a kind of a inherently spatial and aspatial study. You could have done this just looking at the individual level risk factors on recidivism. You could have done this just looking at the neighborhood level risk factors. But of course, when you do a multi-level model, we were able to look at a combination of both, which also found very interesting results. The nice thing about the work I do and why I like spatial statistics and its use in crime science in particular, and is its actual implication for practice and policy. I know that very hardcore statisticians don't kind of look at the appliedness, I guess you could say, of their work, but the work we do and I do specifically for New Zealand context, I wouldn't say much in South African context, directly drip feeds into tactical, operational, and strategic feedback loops and intelligence loops for police and how we can use this information. I'm recently signed, as I mentioned, a contract with New Zealand Police who can get gang research, and the work that we're doing there is directly feeding into upcoming policy, which is very nice to see that the work you do is not just sitting on some academic journal that no one really reads, but is actually having some kind of effect. Okay, so to end off with some of the excuses, and I've only got one slide on this, so fear not. I could speak again a whole hour on this, but I'll just highlight some of the issues, and some of you may be familiar with these. And I mentioned right at the beginning the issue of data availability. One of the biggest limiting factors on more than a handful of people doing spatial crime research using spatial statistics in South Africa is the availability of data. In fact, I got a request yesterday from someone from the Western Cape who asked for a contact in this regard. Data is very guarded, and there's a very tense relationship. I can give you a very clear example of this. I'm doing work at the moment with the Hatfield CID, which is a community improvement district area located adjacent to the University of Pretoria. And every week, the Hatfield CID director gets information directly from the Brooklyn Police Station, including points of crime, to help the CID manage the safety and security of mainly students that live in Hatfield. There was an expose on Carte Blanche about 2 or 3 months ago about the Strip, which is an area adjacent to Hatfield CID, which has a high number of student pubs and nightclubs. And I've been getting data from the Hatfield CID through the SAPS And the minute that carte blanche episode hit on the Sunday, from the Monday, the Brooklyn Police Station, from top down, were told not to disseminate any information to the Hatfield CID again. And that was, the Hatfield CID had absolutely nothing to do with the carte blanche, a story about crime in the strip adjacent to the University of Pretoria. And since then, 3 months ago, there's been no crime coming. So it's very fractious, it's very unpredictable, and this is very frustrating to forge relationships with the data custodians. There's often other data issues such as misalignment. You can see the map over there. That's the old City of Tshwane boundary overlaid, police precinct boundary overlaid on subplaces, and they don't align at all. And there are various aerial aggregation techniques that you can use to kind of force the levels of aggregation and align them, but it's often fraught with, obviously, error. There's often geocoding issues. Geocoding is the process of mapping crime to that point. So each point is an X and Y location, and you need to have an address in order to get the X and Y location, but a lot of addresses are informal or just fraudulent. The crime statistics that we do have access to are not available online broadly and accessibly. They often released annually, although that has been reduced down to quarterly. But there's very little information that is obtained from the crime statistics and very little data analysis you can do with them. The skills and competencies and the support is often lacking, both at the SAPS and within kind of broader, within stakeholders that are interested in this. And this obviously limits collaboration, which means that a lot of the time the work that I've done has often been either on my own or with a few colleagues who are kind of hanging in there in this space, either locally or and of course internationally. People are always more than welcome to collaborate with South Africans, but it's often the data that's most often the problem. I'd like to give special thanks to a whole lot of collaborators on the work. I did mention right at the beginning that this is a very broad-brushed, whirlwind kind of information overload presentation, but I thought that I ran this by Inga, and I thought to her, just to kind of get people interested in seeing the kind of work that can be done without really a deep dive into one particular technique or one particular output is more beneficial for people that are unfamiliar with this research space than doing something kind of more detailed, I guess you could say. So thank you very much, Prof. Deber, and people for listening. Kind of reminded of COVID, speaking in front of a computer screen, and hoping that people are listening. But yes, I'm more than happy to answer any questions if I can. If I can't, I'll refer you to my colleagues. And if anyone would like to take the conversation or contact me privately about any aspect of the research or potential future research, I'm more than happy to engage.
Thanks, Greg. Yeah, you've taken a full hour with the presentation. So let me just see if there's anyone that needs to leave and have a question. So if I can take those questions first, and then if others can stay for another 10 to maximum 15 minutes, we can do the rest of the questions. Yeah, by a show of hands, if someone has a question that has to leave. Okay, I don't see anything. So let's start with anyone else. Any questions for Greg from anyone else? Don, please go ahead.
Thank you. I just want to ask Greg, I saw you had a slide on crime in gated communities. Could you please share some of the findings from that study? Thank
you. Sure, Don. So that was work that I did a number of years ago with Karina Landman, who's a professor in our town planning department. And there we were interested in looking at whether the risk of crime occurring in gated communities, the gated communities we had at the time were not the big estates, if I remember correctly, but they were more kind of boomed off neighborhoods, which I live in one, rather than like an estate like Midstream or something like that. And we looked at the burglaries that had occurred within the gated communities compared to burglaries that occurred on the periphery of gated communities. And we did find some evidence that not all gated communities are completely immune to crime, that there were instances where gated communities did have higher rates of crime than their surrounding areas, but there was a lot of variability there. It wasn't uniform. There was some gated communities that didn't have any crime and some that had more crime. So that was very difficult to untangle, if I remember correctly, because it was probably down to the actual nature of the gated community itself. And a lot of the times gated communities can be breached, and there's different characteristics of gated communities. So, for example, some have patrols, others have just just someone at the entrance and the exit managing access, and some have different types of borders. Some have very high, electric fences, and others just have, it's bordered by houses. So we did find some evidence of that. But if you contact me on email, then I'll be happy to send the paper to you.
Okay, thanks, Greg, for that. Next is Renata. Go ahead, Renata.
Thanks. Thanks for a great presentation, Greg. I was wondering about the research that you did with the line segments, the road segments. How did you choose, the segment length, or how did you come up with the segments?
Yes, that's a good question. So initially Kayla, we kind of thought about it, and once we had, what we initially did, if we have the line segments, we did a 50-meter buffer around each line segment. The reason we chose 50 meters is it's roughly, it broadly approximates a cadastral block in Khayelitsha. So that's a block where you'll have a house on it. So we figured that any points that occurred beyond the 50-meter buffer, we had issues on the geocoding accuracy, and we also were not sure whether that crime could really be linked to that street. So after we had buffered that, we then snapped the points to the nearest line segment. Now, of course, if you just do a color-coded line segment, the longest road is most often going to have the highest amount of crime just because it's the longest road. So we then looked at doing a crimes per meter as a rate for a line segment. We also played around with the idea of doing a crime count, and we divided each road length into, I think it was 50-meter segments. So if you had a road of 200 meters long, but it was one segment, we divided it into 4 segments of 50, and then we snapped and then did a color-coded for that. We found that the rate was probably the best description of the risk. At the moment, I mentioned briefly in the presentation that we're now combining that with the amount of facilities that road intersects. So if you have a street segment that intersects, for example, an alcohol outlet, she's busy developing it's kind of like a street risk assessment, because oftentimes if you have 2 street segments but one goes through a less affluent area, it's most likely going to have more crime points. So we're trying to control for that, as well as look at the characteristics of the street itself in terms of its the speed limit and whether it's a double lane or a single lane. I hope that answers
That's
your
really,
question.
really interesting. Oh, absolutely. And I'd love to see the paper if there's one in the works when you're done.
Yes, yeah, sure, no problem. If you send me an email, then I'll send it to you.
Okay, will do. Thanks.
Okay, thanks, Greg and Renata. Okay, next is Mufundu.
Thank you so much for such a beautiful presentation, and I really appreciate being here today. I just want to ask the question, perhaps based on some of the research you did on the multi-level regression, because I'm doing similar research, but I'm not a geospatial or person who's trained in GIS. I'm a statistician, and I was trying to do multi-level modeling on the crime statistics, but I've encountered the modifiable aerial unit problem, and I'm asking myself how you're able to resolve it, because some of the crime stats are collected, actually the crime stats are collected at the police station level, but some of the population statistics are at a municipality. Yeah, so I'm asking how are you able to resolve that issue, because with the census tracts, it's not the same as the location or the tracts used by SAPS, and it's also not the same tracts used for other purposes. I'm just asking myself how are you from a geographical perspective able to resolve the modifiable aerial unit problem? Thanks so much.
Yeah, that's a good question. The simple answer is you aren't able to solve it. You know, if you have, it helps if your data is very fine. As soon as you got at a spatial unit level, I mean, as soon as you start aggregating, as soon as you start going up to kind of a very coarse level like police precinct or municipality, then it becomes very difficult, because there's quite a lot of variability in the sizes and shapes and areas of different police precincts and municipalities, and that does have a major impact on your results from a modifiable area unit problem. You know, it's less of an issue if you have points, for example, because then you can kind of construct your own. You can place a grid over the study area or something like that. But yeah, I mean, I don't think there is really a solution. The only thing I can think of is that if you can, there is some literature on this. It is quite advanced, but there is some literature on ways in which you can deal it and different types of zonation and techniques. And if you send me an email with your kind of providing a broader outline of your aims and objectives, I can maybe think of forwarding you this information. But you know, there's really no solution to this. I teach my student the issue of gerrymandering, and there's a really interesting study done in the United States about how, you know, gerrymandering accounts or pretty much predicts the US election. And gerrymandering is a modifiable aerial unit problem. So it's very difficult, and there's no real solution to it. But there are ways and means to try and minimize its effects, and I'm happy to help you if you send me an email. I can hopefully discuss this with you in more detail.
Okay, thanks, Greg. And finally, we have Tinus. Tinus is also involved in crime analysis, but he does this more from a qualitative view rather than quantitative. And some of the people that you mentioned, Greg, are from his group or have been in his group, like Karina Landman and also Anthony Cooper, that's currently in his group as well. Tinus, you can go ahead.
Thanks, Pravesh, and Greg, thanks very much for a very interesting presentation. Yeah, I actually just want to support you in two of the responses that you gave just now. The one regarding the study that you did with Karina when she was still in our group here at the CSIR on gated communities. And it has similar problems that we have with anything there where you need data. One of them was that it's very difficult, and it becomes more and more difficult nowadays, of course, as you've just mentioned, to get data, point data, for inside and outside a gated community, whether it's a private development or whether it's a street closure. The inside and outside data is often the challenge. We did some work recently with Professor Rudolf Zinn from UNISA at the time to try and see also what happens inside and outside gated communities here in Pretoria, and we had to use the data that we got from the private security. And I mean, there were some interesting results, one being that where there used to be housebreakings before the closure, that became theft from cars after the closure. So it's like choose your crime, basically. And then just also on the question just now about, police precincts and other boundaries. I think Peter Schmitz also at some stage, who's also with the CSIR, did some work in trying to find a way of making these two, they can't align, but at least that you can use the different groups or the different boundaries in a way that where you can use the crime data. And then just lastly, Greg, your study about green space, I found that quite interesting. But again, I think there we have the challenge that police station precincts will include if you just look at the one in Pretoria with this police station, Central Police Station, it includes the city centre as well as the Groenkloof Nature Reserve. So again, if you want to take it further, you need to be much more, you need a finer grain, and I'm sure you understand or you agree with that, but it just shows you that, you can't just use anything to make decisions, but it would lead you to making better decisions. So thank you very much for sharing with us.
Yeah, Tennis, I mean, we know each other well, so all you say is accurate. I mean, I will say this, that at my last discussion with the Brooklyn police and the Hatfield CID was the Brooklyn commander was saying that I think 2 or 3 months ago they boomed off one particular area of Waterkloof or Waterkloof Ridge. I'm not sure where or what, but the commander was saying literally like a flip of a switch, the crime shifted to Linwood and Menlo Park. And of course, you need to. That's very anecdotal, but he put it down almost exclusively to the booming off of that area. So these kind of trends definitely happen, and it's it's not unknown. It's kind of things that you can predict. And the green space, this was just a study that I was asked to collaborate on, and it was mainly driven by Zander Venter. It was a national study, so it looked at a few, over 1,000 police precincts, and of course, when you average, you're obviously going to find something just in the law of averages that may not be there, and you saw the effect sizes were quite small. So yeah, I take that with a pinch of salt. There was some evidence that there is some effect, but I would also say that if you look at the urban geography of South Africa, you'll also find that township locations, almost by design, if you look at the apartheid city, were placed in areas that are distinct and often where there's almost zero greenery. I was given a radio presentation. I was asked to comment on this on the radio in the Cape, and the one presenter to kind of identified that and said in Cape Town in particular, the areas where all the major townships have almost no greenery whatsoever. And then that's not a consequence of people not wanting greenery. It's just a history of the country and our kind of urban spatial morphology. So there's the observations you made are valid, and thanks for them.
Okay, thanks, Tennis and Greg. Don?
Thank you. I just have 2 questions. The first one is on the access of data. You talked about how difficult it is to gain access to especially crime data. So I'm just wondering, what is it that can be done by academic institutions to force politicians or authorities to release the data. And secondly, I'm interested in, like I see on Twitter and on the news, there's a lot of cash in transit crimes happening all over South Africa. Which one I saw recently in Durban, and there was one recently here in Tshwane on the R8 and so on. So I just wanted to ask you if you know of any papers or any studies that have been done about cash in transit crimes, looking at them from a geospatial location. Is there anything done on that? So I'm actually interested in doing perhaps inviting a paper on this. So I'll be in touch with you. Thank you very much.
Yeah, Don. So I mentioned that I was at this CRIMSA conference about a month ago, and one of the presentations, probably the most interesting one that I looked at, that I attended, was of a PhD student, I think at UNISA, who had access to a whole lot of cash and transit information. It wasn't a spatial study, so they looked at, he looked at the process that is undertaken when police arrive at a scene of a cash and transit heist. They looked at characteristics of the cash and transit heist, money stolen and vehicles involved, and whether weapons were involved and what types of weapons. It was very interesting. So if you send me send me an email, I can forward you the name of the person who had that study. I'm not aware of any study in particular that has had any kind of spatially mapped cash and transit heist incidents. I mean, there's a lot of anecdotal evidence that it occurs, for example, near major intersections and close to on highways and major intersections. But there's also evidence that occurs on rural roads between, Makadu and Beitbridge. So it varies. But I think it would be a great study. It's interesting that you mentioned that, because in the last presentation I gave to police, I did indicate to them that this was something that is very topical and controversial, and I'd be happy to do a study on it if they gave me access to the data, and they were still reluctant to do so, which kind of answers your first point, and that is that it's very, very difficult to get. There is a process involved, and I can forward you the documentation that you need to fill in and to whom you need to present it to, and I'm happy to do that. And my experience also is that certain provinces are more receptive to data requests than others. My experience, particularly recently, the Western Cape are very, very much more open to data requests, even at point level crime data, than certainly Gauteng, depending on your context in which you wanted to study. But I will. It's not a matter of just contacting the nearest area commander. That will get you nowhere. So I'll give you this information if you want, if you can contact me.
Okay. Thanks, Greg, for that. Is there any other questions? Suleiman, please go ahead.
Thanks, Pravesh, and thanks, Greg. Greg, my question is on the training components of things. What are your thoughts around the training, meeting the training, both current and future, and whether or not academic institutions are doing, in your view, enough to bridge the gap in this regard, especially in light of the new dimensions coming in to bridge this whole aspect of the DAC figure of crime, where you have supplementary data coming in from other sources, cities with their structures generating additional drone data, law enforcement data, and all of that. What are your thoughts generally? I'd like to hear. Thanks.
When you say training, I assume you mean of people doing crime analysis. Is that what you mean?
Correct.
Yeah. So I mean, it's very interesting, and I do, in this regard, I do have some sympathy for the police. I was once given a tour a few years ago of their facilities and their resources in Pretoria East, where crime intelligence is relocated, and it's actually very impressive. And the director that I spoke to said that the access to information that they have and the facilities and the software is comparable to what Scotland Yard and the FBI have. The problem is the skills and competency of the people there. Nominally, each police precinct should have someone doing kind of rudimentary crime analysis, but that's not the case. Most are self-taught or self-trained, and they come from within the police. It's very rare that they would or even able to hire externally. And the problem, the director told me at the time, was that an interested SAPS member who maybe has some capability or skills and would like to get into this part of policing, oftentimes where they spend a lot of money upskilling, the minute they have these skills, they move into the private sector or they get headhunted, where they get often kind of much better paying jobs. So, the facilities I saw were standing vacant because there was no one there that they were working on it, which speaks volumes. And there's a lot of kind of things you can untangle there because there's no clear pathway to be a crime analyst, for example, and this is becoming increasingly a pathway in other countries, more developed countries. And so you often have a lot of data, or you have a few analysts doing work for the whole country in some instances. I ran an SAPS workshop about just before COVID for about 20 crime analysts that flew in from around the country. And to attend. It was a full week, and we went over a range of issues. And at one point, two of the crime analysts showed me the system that they're working on, and I mean, this was a system that wasn't even mid-1990s level. It was really something almost like a MS-DOS kind of first version of GIS software. So, it's they're fighting an uphill battle, but they're really good people. They mean well. They're trying their best, and I just think that that it's very difficult to get into. Most of the people are kind of self-taught, and if you want to get into it as an outsider, it's almost like you have to take a research or academic path, or otherwise you're not going to make much headway.
Okay, thanks, Suleiman and Greg. Are there any other questions before we can end? Okay, if nothing else, we'll end the session. Greg, thanks very much for the presentation. So I just have two statements. The first one is that I think the presentation worked very well. I liked the way it was presented. In that, you showed various different examples. The methodology that was used in these examples and what you arrived at, so the conclusions. It will give people a good understanding as to what was actually being used and done for that type of study. So I think it worked really well the way it was presented. And then just the second point I wanted to make is that, data is always an issue. Having the data and then also having reliable data as well. But I think the work that you are doing and others are doing as well, I think that would really assist in people collecting the right type of data, and then also recording it correctly as well, because I think that is also another big problem, how the data is being recorded as well. So I think, thanks very much for the presentation. I enjoyed it, and I don't know if you have any last words before we can end.
No, just thanks again for the invitation, and if anyone would like to interact, I'm happy to collaborate off the group.
Okay, Inga, I see you have joined. Do you have any last words before we close the session?
Don't think she's here.
Okay. Okay, I think she just started the recording, but she's on something else. Okay, so Greg, thanks very much, and you take care. And
Thank you.
yeah, I'll inform the people of the next presentation. So Inga has scheduled quite a number of spatial stats presentations that's going to be held over the next few weeks. So we'll just communicate on that. Thanks a lot. Take care. Enjoy the rest of the day.
Bye-bye.
Bye. Bye.